Hi everyone. I will speak English. I'm Max, and today we're gonna speak about how to make your web application real time. And this is the link of the slide. So if you like, you can visit it, and I will show you later. And you can bring it back to home. I will put on some references and some data. We will invite you to play with us. So there's a demo that please get ready with your cell phone or your laptop, and I'll show you a link, and you can join us. Okay, like a count of 1 minute. Okay, I bet everyone is ready. Okay. So join the demo now. The link is hackmd.io/ParisJS and -realtime-demo. And Yukai is my assistant. He will help me. Okay, I'll read this again. hackmd.io, hackmd.io/ParisJS-realtime-demo. Oh wait. Sorry, it's a little bit long. I should make it a little shorter this time. Okay. Let's wait. Okay. So this is HackMD. You can see this left side is a text editor. The right side is a render. And here you can play with us. Just use your cell phone, your laptop, and yeah, everyone can just click here. Yeah, try. Sorry, you can try to edit anything that you like. And I'm showing some features we have here. So everyone just click the checkbox right now. So we need a stable network. So yeah, a lot of people here. Okay, good. So as you see, it's a collaborative text editor that's related like what I'm going to say. And for the demo, we have a checkbox, and we can drag and drop images, and we can embed some videos, and you can put a markdown link, and also you can leave a comment. And this is a full version control, so it has full version control, so you can see at the top right the menus, see who edited which part. Yeah, so the network is not really stable here, and yes, because it's used real-time technology, so you need it. Okay, we have 40 people here. That's cool. And you can put a different notes link here and make it a book, and you can share this book to other people, and you can like try different notes at once. Okay. Okay. I'll leave this to you, and you can try later, because I think the networking here is not very stable. But yes, we put this is cool, and we support emoji. We support a lot of things. Yeah, with Vibe. Okay. Yeah, it's a playground. You can put up videos, you can put a blog, and you can insert some code here, so it can be automatically syntax highlighted, so you don't need to worry about it. Anyone who's familiar with Markdown, is easy to use this tool to be collaborative writing documentation. Yeah. And you can drag and drop an image here, and that's very cool, because you don't need to worry about where to put the images, just like drag and drop, and it will upload to the Inker, and it's automatically inserted here. Okay, I think that's it. So I'm CTO of HackMD. We try to build a community with open collaboration. We are a Techstars-based company, so Techstar Paris. we are trying to helping developers to enjoy writing documentation, and we know it is hard. We also help open source technology to build an active developer community, and that's why you are here, is a community. Again, I'm Max. I'm CTO of HackMD. I love great product and build them. I'm developing my dream with coding. So what is real-time? Real-time enables users to receive information as soon as it's published by its authors. It's a definition. It just looks like this. You see there, in your right hand, there's a client as you, and you send a change to the server, and the server will broadcast the change to other clients. Okay? So how fast we'll consider is a real time? Anyone have an answer? Like how fast it will be? 200 milliseconds? Yeah. Okay. So 60 FPS makes a smooth video. Yeah. So 6 frames per second means a millisecond divided by 60 frames. So it's 16.67 milliseconds per frame. And you know what? 16.67 milliseconds for such a computation. If you need to do any calculation in this period, that is too short. Even more, the average network latency is 70, so it's nearly impossible. As this image shown, the right hand is your client, and you send the request is 70 milliseconds to a server, and you want to show the result to other clients, it costs another 70. So it's 140. So it's hard to feel it's real time if it only shows when the data arrives. But you can still feel the modern website is pretty quick, pretty real time. But how can they do it? So you fake it. That's what modern web app does. This tag, we call it optimistic lock. So you show the result as soon as the user inputs it, and you put the actual operation into the buffer and send to the server later, and you roll back if it fails. So you assume the result is correct, and if you fail, just roll back. So the user will think, oh, it's pretty fast. So what makes the web real time? You need a network. Yeah, you need a network. Also, so the server can receive your changes, and the other clients are able to receive the updates. So let's see how the traditional HTTP works. Traditional HTTP model will be like the client sends the request to server, and the server responds data to client. It's pretty much like this. So the client said, I want the index, and send the request to the server, and the server said, here you are. But it's one-way communication. So the server can actively push data to the client, but real-time requires to send updates to the client. So this is not a way. So sometimes you just want that you can do that. You want to push some data to the client, but you only can have one way. So there's a model called long polling. I think everyone might know this. So the client sends a request to server again, but it keeps the connection open. And client waits until the server sends back the data. The difference is the client asks the server anyways, even you don't need anything, you just ask, but because the client don't know. So the server will respond when it has data. It's called long polling. Still one-way communication, but it works for a long time. Before the next technology, I cannot tell. And the HTTP 1.1 is half duplex. So traffic flows only go one direction at a time. So if you want to go another direction, you just need to wait. And HTTP is stateless. So you need to send. You don't know if the other side is open connection already, or they shake hands with you already. So you always send the hello, the shake hand data, you always send the redundant information because you don't know the other side's state. So it calls every request and response. That's much if you need a very stable connection. Pretty tired. So that's why we need WebSocket. WebSocket comes to rescue. WebSocket is bidirectional communication. You have a smaller data frame compared to HTTP is only 1/3. It has lower latency. It's almost 4 times faster than HTTP. Here's a reference. If you have the slides, I will show you later. So it will look like this one. Like the right hand is you, the left hand is server again. But as soon as the connection are established, both sides are always ready to send and receive data. So you don't need to shake hand every new connection. The efficiency, we have a table here. You can see the HTTP, the overhead will be always hundreds, like 100, 200 bytes, but the WebSocket costs 2 to 6 bytes per request. The latency, the traditional model will be the new connection every time, and the WebSocket will never use a new connection on sending a request. You'll use the existing connection. So the latency of the long polling, because you just send anyways. So the time you have here, you just need to set up the next request because maybe you just got the data, so you need to send the long polling again. But for WebSocket, there's no waiting. What can you build with WebSocket? Let's see some examples. So first is us, HackMD. It's a collaborative text editor. And you can build a game. It's called Agario. It's a pretty famous game, I think, on the internet a few years ago. It's you're just acting like a cell. So you're a small cell and you'll move on the map. And when you encounter other cell, if you're bigger than the other one, you will eat it and you will grow. So this is just like Smash Bros. Just like everyone just hit it on the internet, and it's an online multiplayer game. It's super fun. So you will send your coordination to the server every time, and you will receive other cells coordination every second too. Yeah, and you can build an online chat room. Here's an example that provided by the Saki.io. So if you want to have an anonymous chat room, this is the tech you need. Also, GitHub uses to update pages. So if you stay on the issue page, when other people comment, you will see the comment immediately because it's sent from the WebSocket. Also, as the issue have been closed or reopened, also the pull requests have been changed, etc. But there's always a catch. You can see in this can I use map table, you can see the IE version 6.9, nobody cares about this. But Android browser 2.1 to 4.3. The 4.3 is the one thing I want to support, but it's not native supported. That's why we need Saki.io. It's time for Saki.io. Saki.io established the long polling connection first. That means almost everyone supported, as long as you support HTTP 1.1. And you will try to upgrade the WebSocket transports. If it fails, just fall back, use long polling. So now everyone is happy. Saki.io even provide more intuitive API for the no more real-time application needs, like easy to broadcast multiple clients, like you need a chat room, right? Like a building logic for rooms and namespacing, so you don't need to worry about dividing the message to different rooms or to different apps. That's quite cool. So let's try to make a chat room with Saki.io. For installation, you need to include a small script in your HTML, and the package is called Saki.io-client. Yeah, just include it. And for the server side, you need to use npm to install the Saki.io package, and you just create an HTTP server that the Node.js native supported, and bind with the Saki.io in your app, and listen to the port. So first, the client will try to establish the connection. By doing this, just like a pretty normal constructor I/O, yeah. And the server listens to the connection. So when the server listens to this connection, it will receive the socket, and you can log it, and you can find more events to the socket, like when it's disconnected. Server can broadcast to everyone, like when the chat room is ready. So the IO emit room message is like, it will broadcast to everyone that the real room is ready. The client will emit event, like the socket emit, and this is the event name, and this is the event data. This is a message, hello world. So the client emits chat message to the room. The server listens to this same event name that's called chat message, and you will receive the message here, and you can log it. And now you receive the message that's sent from the client. You want to send to the other people in the room, so you will send to everyone except for the certain socket, that's you. So IO.connection, that means you're connected. And when you send a chat message, I will broadcast to everyone except yourself. Okay, and that's pretty much the chat room. So thanks to Saki.io, we can build a real-time web application app really, really fast. Just maybe this will be a week-long work turned into a few hours. Also, there is a technology we call server-send events. It as an alternative for sending from server to clients. That's opposite way. So server-send events, that's one way. Only servers pushes to client. It's part of the HTML5 standard. So I don't know, but maybe not much people heard about it. But it plays good with HTTP2 because HTTP2 is full duplicate. That means you can send the data of two ways in the same time. And it automatic reconnect, and it provides some event binding already. So you don't need to build it because the browser native provided. So this will be the diagram that you are the client, and the server can push data actively. But there is always a catch again, like the IE and Edge doesn't support it at all. Until now, it doesn't support. But you can easily be totally failed. So as a comparison, there's a comparison table that's showing this. HTTP can send direction is the client to server, that the client sends a request to server. The WebSocket will be bidirectional. Server send event will be server to client. The native browser supporting HTTP is almost 100. WebSocket will be 90. And the server-side events will be 84. Please be noticed this before in the polyfied. So the overhead of the HTTP is pretty high. The WebSocket is low. The server-send event is medium. And the latency of HTTP is 1 to 2 seconds. WebSocket is below 1 second, and while as server-send events is mostly 1 second. So you can leverage this advantage of the web application, like choose the best way you like to compose your applications, like how often you need to send the data, how quick you need to receive the updates, and choose the one you like. So recap, you can fake the real-time experience. There's no need to always be real time. And the long polling is the old way to be real time, and the WebSocket is a real bidirectional communication. Saki.io supported it all, and the server-side events with HTTP2 can be alternative. So if you really don't need that, okay. That's much. Thanks for listening, and welcome to follow my GitHub and Twitter, and please visit HackMD.io. And yes, that's it. Thank you very much. Do you have any questions? Yes.
How do you handle conflicts between different changes?
You mean like text
Yeah.
conflicts?
Okay.
So there's another topic, but I will briefly saying about this now. It's like there's several algorithms you can have, And for the text editor, we use the algorithm called operational transformation. That's a way that you send your, they will always put your text operation into three. One is retain, that's mean how long the character you don't want to change. And the insert means at this part you want to put some text. And there's a delete that you want to, how many characters you want to delete. And you will always put your operation at this format and send to the server. And the server later will decide the orders and send it back to you. So no one is conflict ever. And other things like there's a algorithm called CRDT. That's you wrap your operation that's in a format that never conflicts. And also there's a way, the old ways to lock, like where everyone, another client is doing this part, you will lock this area, and you can change it until it go to next area, it will be unlocked. That's the old way, but it works, right? Yeah. Did this answer your question?
Yes.
Okay, good.
Thanks for the talk. Based on your comparison slide, is there any advantage in working with server-sent events as well?
Yeah. Did you mean this table?
Yes,
Yes.
the last one.
Yeah, so for WebSocket, it's bidirectional. So the client and the server always ready for sending data. But sometimes you only need the server to client for like updating your status, updating your stock. Yeah, you don't need to the client send it back. So now it's time to choose SSE. And with HTTP2, you can have different chunks. So you don't need to send the request at once. You can put it in data frames, so it's faster. And the overhead might be lower. Yeah, to build a real-time server.
So is it the only approach to use HTTP2?
Yeah.
Okay.
Yes.
Thanks.
Yeah, so when it comes to scaling, I don't know if it's possible for WebSockets to still use like load balancing or something like that. I don't know, can you still use it?
Yeah, because HackMD have a lot of users, so we also use load balancers. So for load balancers, because when you put some data in one instance, that you might put some data in the memory. So if you do load balancer, that means you have multiple instances. So if you put the data in one memory, the other instance will never know that. So we'll use a method we call the sticky hash IP table. So whenever your IP go to this instance, the next request will go the same one. It will never change the next one. So it can be load balanced.
Which format do you use for your messages?
Format?
Messages. It's JSON.
Yeah, actually, for Sakia, you can send any type. You can send just string or JSON or binaries.
Okay.
Yeah, and it will do the compression for you. Yeah.
Okay. That you use JSON.
Yeah, we use JSON. Yeah. So the WebSocket will do the compression for you, and the SSL will, the transport will do another data transfer table compression for you. So it's actually double compressions, double compressed. So before we used it looks like a base 64. Would be it's a very long time ago, HackMD used a base 64 encode, but actually it only makes the data longer because it's hard to make it chunk. So later we just transfer to pure JSON. Yeah.
Thank you.
Merci beaucoup.